Welcome back. So we are now going to discuss module 0.2, which is, I'm going to discuss a few sample attacks. So of course, we are going to discuss these attacks and many other attacks in a lot more details during the course. But just to give you an idea in the first class, what kind of attacks can happen or are happening, we'll show you some of the examples. So I already discussed this, that there are a lot of buggy software and there are a lot of gullible users, and therefore cyber criminals are making money out of this cyber attacks and various ways of exploiting their systems. Now, one of the major problem in the world today is that there are many hackers that are sitting there in various countries, mostly in Eastern Europe and Russia, who actually are maintaining a large number of botnets. And this, some of them actually have millions of zombie machines under their command and control. Now, why would you want to do that? Why would you want to own machines clandestinely? First of all, often need a variety of IP addresses when you are doing an attack or spamming people's email boxes. And actually, this whole idea of botnet came from spamming. Like in late 90s and early 2000s, there used to be a lot of spam emails generated from these botnets. And since they have different IP addresses, it is often difficult for various spam blockers to figure out that they are actually coming from the same sources. And then bandwidth stealing is another reason, because if somebody owns your machine, then your machine's available bandwidth is being used by somebody else for launching attacks or sending spam emails and things like that. And the attacker's goal in many of these things is that you want to look like you are coming from different users or different machines, and therefore you want a variety of IP addresses, and infected machines or infected phones give you that kind of variety. Now, as I said, the spam, like Storm botnet, was one of the first few botnets that was used for spam. And if you look at the economics of spamming, it turns out that about 12 million pharmaceutical spams lead to one person actually buying that pharmaceutical. So therefore, you have to have very large number of spams if you want to actually make money. Similarly, out of 260,000 spam emails, one result in buying a greeting card or things like that. So denial of service, which is one of the major usage of botnets nowadays, where they launch a number of requests from various members of the botnet to a server, and the server then cannot handle so many requests in that small amount of time, and therefore it fails. So, and most recently, about 3 weeks ago, from December 2016, which was late in October and November, there was a big denial of service attack against the company called Dyn, which maintains one of the root DNS servers. And the way it was done was actually by using a particular botnet called Mirai, which was used on webcams and digital video recorders, which are not traditional computers. So you can see that denial of service attack and botnets are actually now moving into what we call Internet of Things. The economics of this is that for 1 hour of launching a huge number of requests on a website, for example, costs around $20, and 24 hours could cost anything around $100 or little more. So this is not very expensive. If somebody wants to attack your website, they can actually do it by using these services. And these services are available underground in the dark net, and we'll talk about that later in the course. But this is not very difficult to access. Now, click fraud is another reason for owning botnets, because sometimes various sites, if your advertisement is on that site and people click on that advertisement from your site, then you make money. So therefore, you actually want to make it look like that people are clicking on that advertisement from your site, and so this kind of botnets are also there. Second is to actually, you want to own others' machine to actually install keyloggers or various other kind of Trojans so that you can actually steal their credentials, and you can inject ads. And this happens quite a bit nowadays, that if you are actually installing one of these malwares by mistake, then they will actually understand your geographical area and other things, and then start flashing ads on your web browsing, and it becomes really problematic. And also, if they actually put a keylogger on your machine, then your banking password could be easily stolen, and an example of that is the silent banker. So the way it works is that user requests a login page to the bank. So you type www.onlinesbi.com. Bank sends the login page needed to log in. Now this silent banker will then, what it will do is it will inject a JavaScript on the way, and then when you type in your banking credentials, it also goes to the attacker because of this JavaScript. Now this is not the only way, but there are many other ways to do this. So Zeus botnet is also using a very similar technique. The other issue is that sometimes we feel comfortable when we think that our machine is air-gapped, or our machine is not connected to the internet, and we think that it's okay, to be not so worried about security. But example of Stuxnet that actually attacked the nuclear enrichment plant in Iran in 2009 showed that actually in an isolated system also you can spread a malware, and in this case it was the Stuxnet worm, and that was actually sent to the plant by social engineering, and we'll talk a little bit about social engineering later, but this is a way of influencing people to carry an attack vector into a place which is air-gapped, so you don't have connection by internet, but within the plant there is a network, because they use SCADA system, so they have a network, and so this network was affected. The worm replicated itself to various machines, and then eventually changed the SCADA control, and the centrifuge rotation speed was decreased to below critical speed, and therefore the uranium was not getting enriched. And these kind of attacks are very difficult to find until it is too late, because apparently nothing changes. In a distributed denial of service attack or other kinds of attacks, effect is immediate, but in this case the effect is kind of delayed, and this is that's why it's a clandestine covert attack. And this used Windows vulnerabilities as well as Siemens PCS7 SCADA control software vulnerability. So it was quite a clever attack. And this Stuxnet actually made the entire world sit up and take notice that our critical systems like nuclear power generators, thermal power generators, hydro power generators, manufacturing control, your transmission and distribution system, all these things are vulnerable to this kind of attacks, and this kind of led to a lot of attention in the United States, and President Obama in 2013 gave an executive order to create a cybersecurity framework for critical infrastructure, and we'll come to that at some other point. There are server-side attacks. Now, mostly this is done for financial data theft or critical information theft. So one example is Target attack. So in 2013, 140 million credit card informations were stolen. And I will discuss the pathology of this attack in much more details later, because this is a very interesting story that this attack was launched through a very unrelated network. It was the HVAC or the air conditioning system was being monitored by another company in the stores of Target, and that network was not a very critical network, so it was not so properly guarded. And so attackers breached that network, and from that it basically went into the information network inside the store, which connected all the point of sale machines, which uploaded the credit card information onto the servers. And it's a very interesting story, but we'll get into that later. So there is Project Aurora, that was apparently the Chinese attack on power systems in the United States, or at least suspected so. The Facebook attack on Facebook, GitHub, and so on are all examples of server attacks. And one of the way these server-side attacks happen is by, or one of the reasons why server-side attacks happen is obviously stealing information. Another is to actually make legitimate websites carrier of malware, and when the legitimate users come to that website, they actually get infected by what is called a drive-by download. So they come to this website, which is a regular website, and if it is infected by the malware, then they also download that malware on their system. So another problem in cybersecurity today is insider attacks. So Pricewaterhouse did a survey 2 years ago, and then turns out that 29% of the attacks are by some insider. An insider could be disgruntled employee, or it could be somebody who doesn't know what they're doing, and therefore it might be a problem. So here is an example of an insider attack. In this case, what happened is that the Linux kernel that was being maintained in two CVS or software repositories. In one repository, somebody changed the code of this particular function called wait4 function. And in this function, what they did is they added this line here. Now, what this line does seems to be that they are checking some kind of guard conditions, and it seems to be quite innocuous. But if you look at this one, this here is using an equality sign and not equal. So it's not actually checking whether that thing is equal to 0, but it's actually assigning 0 to the current user ID. So as soon as this line is executed, the program that called this wait4 will be now executing in the privilege mode, or as root. So this was hidden in the software repository, but fortunately the person who was supposed to merge the code noticed this and corrected this. But this can happen in your software development environment in your company. So another example, of course, is that Snowden. So many of you might have seen the movie Snowden. So he had access to the secure network inside the Defense Department, and then he brought a CD, read-write CD, which he apparently claimed to be a music CD, and then he was downloading a lot of cable information, and actually this is not Snowden. This was the other guy who actually started giving information to WikiLeaks, and that's an insider attack example, of course. There was a system administrator in the city of San Francisco government who got upset and changed the root password and refused to give the root password to anybody. So the functioning of the city was compromised. And then there was this example of, so UBS is a bank, and in this bank, one of the employee was supposed to get a $50,000 bonus, but he only got $36,000. So he got very upset. So he put a logic bomb. So what a logic bomb does is that it is timed. So he basically designed the code and inserted into the system, so that this code would actually delete all the important files, not only in the local server, but also in 400 different branches of the company. But unfortunately, he was caught, and he was given 97 months of prison time. But so these examples show that people who have the password and other kind of access control into your system, your security system should be such that even they cannot do too much harm, right? I mean, that's the way it should be designed. So because something is password protected or authorized doesn't mean that it is secure. It may not be secure from the insider attacks. And we'll go into more details of insider attack issues later. So that's the end of 0.2 module. And in the next module, we'll talk about the marketplace for vulnerabilities. We hinted at that before, so we'll talk more about that.